Welcome to learners. We have discussed two sections, section 1 and section 2. Now third section is going to uh, on the EEG signal pre-processing. Before this section 1 and 2 is covered with the different brain computer interface introduction, and second one is the what is the EEG signal basics. Now third section is related to EEG signal pre-processing, and welcome to this lecture series brain computer interface course, learning from scratch basically. So what is pre-processing is essential. Why is pre-processing is required in EEG signals? The basics of EEG signals is, so because EEG signals are prone to noise and are different from muscle movements or eye blinks or external electrical activities. So that is introduce a different noise into the EEG signals, that is the brain signals or electrical signals, which is generated from the brain waves or brain rhythms, and that will be should be pre-processed to ensure a cleaner data for accurate analysis. So in order to accurate analysis, in order to get the performance characteristics of any EEG signal or a brain computer interface application, so you have to pre-process the signal EEG before, then you have to go for the further steps. So that is the purpose we have to go for a pre-processing. This is the major step and first step before generating any other waves output. This is the best way of doing a signal removal of the noise and artifacts, and it will be removes the irrelevant signals or noise, and which will enhance the signal to noise ratio. SNR should be increased, so then only we have signal power is more compared to the noise power, so that signal to noise ratio will increases, and will free from the noise. So, and what are the common artifacts or the noise added in EEG is very very generally we are introduced is eye blink artifacts, EOG artifacts, or they are called also slow waves or the blinking artifacts, and other artifacts are the different noises are EMG activities. So the EMG are a muscle activity, which is also high frequency burst that will be generated or added in the main EEG signal. And other type of artifacts are the power line interfaces or 50 to 60 Hz electrical noise, which is added basically in the electrical signals. Okay, then movement artifacts, which is a low frequency distortions. So whenever you move here and there, some movement will be there, and that will be added as a noise to your brain signals, which is generated typically in the brain, and it is a low frequency signal that will be added that will to the main signal, and it will be distort the, or it will be reduced signal power, or noise power is increased. Band pass and notch filtering is the technique basically we will use to filter out these retained frequencies of interest 1 to 50 Hz, and notch filters are used to eliminate power line noise or power line interfaces, example 50 to 60 Hz. And what are the different library used for the filterings of design of these filters in the digital domain is Python libraries, or MNE Python and CIPy are the digital filter design techniques, or libraries used to filter technique to design a digital filter. So this is the software or a simulation based digital filter that will be artifacts will be removed. And another removal artifacts technique is ICA, independent component analysis, which will separate mixed signals and is the best way of removing the noises. And this is the helps to isolate and remove artifacts like eye blinks and ECG signals. So in the ECG also, one of the artifact that is added to the main signal, which is EEG. So sometimes ECG acts like a noise to the main EEG signal. Whenever you have a brain signal is there, and a heart signal will be interfere with your brain signal. So this is also another part of EEG artifacts techniques, in which the noise is added predominantly. And the visual inspection is essential before rejecting components. So another best way of removing the artifacts is visual inspection. So whenever you see the artifacts, you have to remove that artifacts by checking the results of output. And what are the coding you can see in the repeat processing is first you have to load the raw EEG data using MNE Python library and apply the bandpass and notch filters, digital filters, and run IC and remove artifacts and independent component analysis or a technical simulation method that should be you remove the artifacts and visualize the clean EEG signal. And for this purpose you have to use Jupyter notebooks, which is provided in the hands-on experience through again you can use Google Colab. It is available open source. It is also Jupyter notebook also available open source library, so that will be downloaded from the internet, and you can see the how that will be the IEG data will be taken at different data sets, and you have to run that data set and remove the data of bandpass filtering and notch filters, and run the ICA technique and remove the artifacts and visualize the clean EEG signals. Then you have to go for the further steps. So see in the quiz time, so what are the four questions are asked. So just recap the what we have learned today is what is the purpose of a notch filter. Notch filter is to reduce the noise of power line interface 50 to 60 Hz. And what artifact is commonly used by blinking means eye blink or ocular artifacts are mainly caused by blinking. When what is the ICS transfer means independent component analysis. So it is the basic major technique used in all pre-processing techniques. It is the basic idea, so in which you can you interlink with the different techniques, and it is a major technique really used in the EEG signal pre-processing. Now what is the typical frequency range for EEG bandpass filtering is 50 to 1 to 50 Hz, where basically used in the bandpass filtering, and that means less than 50 Hz we can use in the bandpass filtering. So thank you one and all. So today is this is the lecture, and we will see in the next class.